Shrewd Manager Christianity's position. Radiocarbon tests of a corner of the shroud are not valid indicators of the age of the entire shroud. In 1988, 3 labs carbon dated a sample of the shroud. With 95% confidence, they agreed it dates to between 1260 and 1390. This graph simplifies how carbon dating works. Once an organism dies, its carbon-14 decays at a known rate. Linen comes from flax plants. So if we know how much carbon-14 flax had when harvested and what it has now, we can calculate when it died. This insight earned chemist Willard Libby a Nobel Prize in 1960. It is a very helpful tool, but is not foolproof. This booklet lists several failures. Based on historical evidence and stratification, 2 boats found in Antwerp were likely Roman, but were carbon dated centuries too late. The Mammoth of Garonne was carbon dated to 1200 BC, 6,000 years after mammoths went extinct. Parts of the windings of the Manchester mummy date 1,000 years older than other parts. Now on to the shroud. Here is the carbon-dated area before removal for testing. This adjacent section, called Reyes Corner, was removed in 1973. This rectangle shows a backing cloth, where shroud linen has been missing for centuries. Although the samples were destroyed in the test, these nearby sections were retained. In these UV and quad mosaic photos, it's obvious the carbon-dated corner is different from the rest. So different that before the sample was cut, several researchers warned this was the worst area to test. Any chemical process that increases carbon-14 would cause a false test, making the shroud look younger than it is. Here are 3 possible scenarios. Spectroscopic analysis shows the shroud had been exposed to neutron radiation. When neutrons collide with nitrogen atoms in linen's molecular structure, they transform into carbon-14 atoms. Model experiments reveal another scenario. Water used to snuff a 1532 fire could cause excess carbon-14 to bond with the linen. The fire was so intense it melted silver, burning the shroud. The experiments identified several more chemical reactions that could also impact the radiocarbon dating results. A last scenario is that the fire caused an isotopic exchange between the air and the linen. Using 3 different calculation methods, the authors show this could yield a 600-year-old date on a 2,000-year-old cloth. So there are multiple scientific, cogent reasons why the shroud could be much older than the test results. Using high-resolution photos and data from the tested sections, plus threads retained from the corner, scientists identified 2 more simple and compelling reasons for invalid results: contamination and repair. These historical pictures show the sampled corner being handled. And here's one showing the shroud in the open air, surrounded by throngs of people. Over centuries, the presence of microorganisms would form a microbial biofilm on the cloth. If the tests dated both the cloth and the biofilm together, the results would show a younger age than just the cloth. Since contaminants can obviously skew test results, how well did the labs clean the samples? This microbiologist says not well at all, explaining how the lab's cleaning techniques were insufficient to remove microorganisms. Further, the labs violated the most basic principle of analytical biochemistry: know the chemical composition of the material being studied. Without this analysis, there is no information concerning the relative effectiveness of the various cleaning treatments. The second common-sense reason for a skewed date is even more damning. Based on the combined evidence from chemical kinetics, analytical chemistry, cotton content, and pyrolysis MS, this paper concludes the radiocarbon sample was not part of the original cloth and is invalid for determining the age of the shroud. Here are 4 ways the corner differs from the rest of the cloth. First, the corner contains spliced threads, but the rest doesn't. Here's one thread before it was agitated through high vacuum. Afterwards, we see it's really a splice of 3: cotton, linen, and a resiny glue. This discovery is obviously of paramount interest. First, the splice is not at all obvious if we look at the before photograph. Second, the brown resin-like crust could not be seen under the microscope. Third, this shows that this part of the shroud has been managed thread by thread, contrary to the main part of the shroud. This is cotton woven into the threads, not a surface contaminant. The rest doesn't contain woven cotton. Second, the corner contains dyes. The rest does not. See the pattern? The undyed section is where cross threads covered it. A gum dye mordant coating is easy to observe on rayas and retained radiocarbon yarns. No other part of the shroud shows such a coating. Third, the weave pattern, thread size, and overall thickness of the corner fabric are different from the rest of the cloth. The next video discusses this in depth. Fourth, perhaps the most intriguing difference involves vanillin, an organic compound that decays at a known rate. Vanillin is absent in older materials like the Dead Sea Scrolls since it has fully decayed, but is present in newer items like medieval artifacts and the backing cloth. Linen produced in AD 1260 would have retained about 37% of its vanillin. Since vanillin is in the corner threads but not in the rest, the cloth must be quite old. It is thus very unlikely that the linen was produced during medieval times. In sum, we have reasonable doubt that the tested corner dates to the 1300s. But even if it's true of the corner, the rest of the cloth is so different that the tests tell us very little about the shroud's age. Next, we look at one explanation for these differences between the corner and the main. Then we move into the enchanting realm of statistical analysis.